Hello friends, welcome to edenbrain.com. Today we'll see a question on non-deterministic PDA. The question is construct PDA for language L such that L is W raised to R, where W belongs to A plus B star, right? Use final state acceptance method. Use final state acceptance method. So I will say acceptance will be done using final state, right? So now let's try to tackle this question. Now why I say non-deterministic PDA? First of all, why I say non-deterministic PDA? Denoted as NPDA. Now what is non-deterministic PDA? First of all, let's try to understand first, is this language is accepted by deterministic PDA. Now let's try to have a stack operation for this language. If I really want to accept AB, BA. Now previously we seen the same language, instead of W raised to R, it was WC raised to R. W raised to R was the string, so it means A, B, C and then BA was present. Now what was the logic in that time? That time what I did is, whenever I encounter the first A, I will push it, I will encounter the B, Z0 is always there, and then when C comes I will skip this C, and then you will see that B will be top of the stack, and then I will pop out, then A will be top of the stack, and then I will pop out. Like this you will be able to do the push and pop operations for WC W raised to R. Why? Because that is very deterministic, right? Why deterministic? Because we know when to push and when to pop and when to skip. Now here there is a problem, right? There is no identifier as such like C here, right? Here how you will understand, first of all, what is W? That is the problem, right? Here you can see this is the W and this is W raised to R. There is no identifier or delimiter in between like C here, you can see this. So understanding the string of W raised to R form is very hard. You can see that. Let's see the next string. Let's see this string. Now this is also of W raised to R form. Now we as a human being will able to really distinguish between this is W and this is W raised to R, but the stack or the machine will not be able to understand where I will get W and where I will start getting W raised to R, and that's why this is non-deterministic thing, right? It is very non-deterministic. I can't say I will be able to determine where I will get W raised to R started, right? Let's try to have the operation here. Let's try to have the operations, right? Now let's see another string of W raised to R form. AB is considered as W, let's say, then W raised to R will be BA. I hope you understood. Now you can look at, as a human also we will not able to understand what is W and what is W raised to R, right? So this is W and this is, I can say, W raised to R. I hope you understood this, right? Now understanding W and W raised to R is a big problem, and now then when to push, when to pop is really non-deterministic thing here. Let's take this example of 4 A's. What I will do is, for 4 A's, Z0 is top of the stack. When I get the first A, I will push it, right? Now when I get the second A, I will push it again. Now when I get the third A, shall I push it or shall I pop it? That is the problem here. Now that is non-deterministic. For this third A, what to do? Or rather for this A also what to do, we really can't able to say, right? Because we really don't know the length of the string at the start, right? Length of the string will be defined at runtime, right? So that's the problem here. I will show you with the example. Let's take this example for 4 A's. We will try to draw the machine. Now what I will do, I will start with the start state Q0. Now whenever I get the A's, number of A's I can say, right, I will push them. So when I get A and Z0 is top of the stack, I will push that A. Similarly, if I get the next A, means second A, who will be top of the stack? Let's have the stack also. So at the start, Z0 is top of the stack. when I get the first A and Z0 is top of the stack, I will push A, right? So A will be pushed. Now where you will be here, and now when you get the next A, again next A must be pushed, and so what I will do for the A is top of the stack, again I will push it. Okay, so now this second A is pushed in. Right now you can see this, we got the third A, right? We got the third A. As a human we know this, but machine can't understand this is the W raised to R started, right? So machine will not be able to understand, and that's why you require a non-deterministic transition. When I will say that if I get the third A kind of stuff, what I will do, and who will be top of the stack? Yes, this A will be top of the stack, and then what I will do, I will start popping it out. Means for this third A will be top of the stack, and that's why I will pop it out. Now the pointer will move on, and once the pop operation started, I will always try to pop. I will always try to pop. Means for the further A's, if I get a again, last A, and who will be top of the stack? Definitely A should be top of the stack, and then I will again pop out, right? So yes, for the second A is top of the stack, means for the fourth A, this A is top of the stack, and then I will again pop out. And now it says that use final state as acceptance criteria. It means what you will encounter now, you will encounter the epsilon. So epsilon is there, and who is top of the stack? Z0 is top of the stack. Let Z0 be top of the stack and go to the final state, I can say. Go to the final state Q2, I can say. I hope you understood for this thing, and similarly you can do for the B also. So I will have a loop of B same way like for A. So I don't have to worry about now because it is proven for A. Means similarly I can have for the B also. Now there might be one case also. The case which we have to look is, let's say AB, BA is one of the string. You can see this is W and this is W raised to R. Now yes, in that case also you should be able to push. Now you can see this. Let's start with our machine. Z0 is top of the stack. Who comes? A comes. So A will be pushed because Z0 is top of the stack. A comes and then it is pushed. Now you can see this, B comes. Who is top of the stack? B comes and A is top of the stack. That transition is not here, and that's why what I will do is I will say that if B comes and A is top of the stack, please push it, right? So I will push that B also now. And similarly you can see this, if it is for AB, then you might be having for BA like this, right? So BA, AB also is a valid string because this is W raised to R, and in that case B comes first, then you may be having this transition A, B, and then A will be pushed like this. Similarly for that, and similarly for AA, there will be a transition of BB. It means you can see this, if I have 4 B's, and this will be W, this will be W, and this will be W raised to R. What I will do is, for the first 2 B's I will push them. So I will push them. Let's have the stack. Z0 is top stack. So for the first B I will push it. For the next B also I will push it. Right? And now you can see this third B started. Now it is non-deterministic. Why it is non-deterministic? Because you can see this. There are 2 transitions of B comma B. This is one and this is another transition on same state. You remember NFA, on same state, if you have 2 input alphabets of same type, then it is non-deterministic. And similarly I can say that on Q0 I do have the transitions of B comma B for Q1, and same I have the transition on Q0, and that's why it is non-deterministic. Understand? For this and for this it is non-deterministic. Similarly for this and for this it is non-deterministic. Now what I will do is, you can see for B's, 2 B's are pushed here, and now you get the third B. Now you can push it, actually you can push it, or you can actually pop it. So that is the problem here. Actually when you have this machine, you will be not able to sure what to do actually, but as a human being I know that I will start popping out. So I will say that B, if B comes, means third B comes, and who is top of the stack? B is top of the stack, so I will pop it out. Now further I will pop out all the B's if present. So I will say that B comma B, I will pop out all the B's for the consecutive B's. And then what you will do is, yes, now at the finally you will get the epsilon, and for epsilon, if Z0 is top of the stack, yes, Z0 is top of the stack, I will go to the final state saying that it is the acceptance by final state. I hope you understood this, right? Difference between NPDA and DPDA. What is the difference? Actually you can see this, W raised to R is not possible from DPDA. So if you have a deterministic push down automata, this is not possible, but W raised to R is possible for non-deterministic push down automata, and hence I can say that expressive power of NPDA is definitely greater than expressive power of DPDA. Right? So this is only applicable for push down automata. In Turing machine, expressive power of non-deterministic Turing machine is equals to expressive power of deterministic Turing machine. Right? In case of finite automata also, NFA expressive power is definitely equals to DFA's expressive power. Means the number of languages accepted in Turing machine in both the cases are same, rather for non-deterministic or deterministic both are same. But in case of PDA, this is a very important rule. I can say that non-deterministic push down automata is much more powerful than deterministic push down automata. I hope you understood it. Let's try to accept W raised to R using deterministic push down automata. If it is deterministic, what you're gonna do, you will not be able to find who is W and who is W raised to R, and these two transitions are definitely required on one of the state. If you are trying to neglect one of the transition, then definitely you will get a deterministic push down automata, but the problem will not be solved, and hence I can say that W raised to R will not be solved by deterministic push down automata. I hope you enjoyed it. If you have any doubts, please put it into the comment section, and please subscribe to our channel for further videos. Thank you.